Dear learners, we already know that where there is oxidation, there is always reduction. Chemistry is essentially a study of redox systems. A number of phenomena, both physical as well as biological, are concerned with redox reactions. These reactions find extensive use in pharmaceutical, biological, industrial, metallurgical and agricultural areas. Of late, environmental issues like hydrogen economy and development of ozone layer have started figuring under redox phenomenon. After this discussion, you will be able to identify redox reactions as a class of reactions in which oxidation and reduction reactions occur simultaneously. Define the terms oxidation, reduction, oxidant and reductant. Explain mechanism of redox reactions by electron transfer process. Originally, the term oxidation was used to describe the addition of oxygen to an element or a compound. Because of the presence of dioxygen in the atmosphere, which is roughly about 20%, many elements combine with it, and this is the principal reason why they commonly occur on the earth in the form of their oxides. As you can see, the elements magnesium and sulfur are oxidized on account of addition of oxygen to them and get converted to magnesium oxide and sulfur dioxide respectively. Let us examine one more reaction in which methane is oxidized by addition of oxygen. On careful examination of this reaction, we observe that hydrogen of methane has been replaced by oxygen. So, chemists reinterpreted oxidation in terms of removal of hydrogen from it, and therefore, scope of term oxidation broadened to include the removal of hydrogen from a substance. We can understand this with one more example. When hydrogen sulfide reacts with oxygen and forms sulfur and water, this happens by loss of hydrogen from hydrogen sulfide. Hence, we can say that H2S is undergoing oxidation. As knowledge of chemists grew, it was natural to extend the term oxidation for reactions shown here, which do not involve oxygen, but other electronegative elements. The oxidation of magnesium with fluorine, chlorine and sulfur happens by loss of electropositive element, that is magnesium. In the second reaction, potassium ferrocyanide changes to potassium ferricyanide by the removal of electropositive element potassium. Learners, now summarize the definition of oxidation is defined as addition of oxygen or electronegative element to a substance, or removal of hydrogen or electropositive element from a substance. Now let us understand what is reduction. In the beginning, reduction was considered as removal of oxygen from a compound. However, the term reduction has been broadened these days to include removal of oxygen or electronegative element from a substance, or addition of hydrogen or electropositive element to a substance. There are few examples of reduction process which are shown here. In first example, removal of oxygen from mercuric oxide takes place. In second example, removal of electronegative element chlorine happens when ferric chloride changes to ferrous chloride. In third example, ethene gets converted to ethane by addition of hydrogen. Look at some more examples. You can see that addition of electropositive element, that is mercury, takes place when mercuric chloride changes to mercurous chloride. By observing closely, you will notice that simultaneously stannous chloride changes to stannic chloride by addition of electronegative element chlorine to it. There are two more reactions mentioned here. I hope now you will be able to identify the species undergoing reduction. It was soon realized that oxidation and reduction always occur simultaneously. Hence, the word redox was coined for this class of chemical reactions. Let us understand oxidation and reduction with the help of an example. In the reaction given here, identify the species undergoing oxidation and reduction. See first reaction. In this, hydrogen sulfide, that is H2S, is oxidized because a more electronegative element chlorine is added to hydrogen, or a more electropositive element hydrogen has been removed from sulfur, whereas chlorine is reduced due to addition of hydrogen to it. In second reaction, aluminium is oxidized because oxygen is added to it. Iron 2,3 oxide, that is Fe3O4, is reduced because oxygen has been removed from it. In third reaction, we may infer with the careful application of the concept of electronegativity only that sodium is oxidized and hydrogen is reduced. Reaction third chosen here prompt us to think in terms of another way to define redox reactions. We have already learnt that the reactions given here are redox reactions, because in each of these reactions sodium is oxidized due to the addition of either oxygen or more electronegative element to sodium. Simultaneously, chlorine, oxygen and sulfur are reduced because to each of these the electropositive element sodium has been added. Dear learners, have a look at the reaction. When fluorine undergoes hydrolysis and forms hydrogen fluoride and oxygen gas. This reaction cannot be explained by classical idea of oxidation and reduction. So, there was an urgent need to extend the classical concept to modern concept in which we express redox reactions in terms of electron transfer reactions. Let us understand the concept of electron transfer in redox reactions. For this, consider the reaction for the formation of sodium chloride. For convenience, this reaction can be considered as the combination of two separate steps. One involving the loss of electrons from sodium and the other is gain of electron by chlorine. Each of the above steps is called a half reaction, which explicitly shows involvement of electrons. Sum of the half reactions gives the overall reaction. 2 moles of sodium in solid state joins with 1 mole of chlorine gas and gives 2 moles of sodium chloride in solid state. This reaction suggests that half reactions that involve loss of electrons are called oxidation reactions. Similarly, the half reactions that involve gain of electrons are called reduction reactions. In reactions, sodium, which is oxidized, acts as a reducing agent because it donates electron to each of the element interacting with it and thus helps in reducing them. Chlorine, oxygen and sulfur are reduced and act as oxidizing agents because these accept electrons from sodium. To summarize, we may mention that oxidation is loss of electrons by any species. Reduction is gain of electrons by any species. Oxidizing agent is acceptor of electrons and reducing agent is donor of electrons. Let us understand the concept of electron change with the help of an example. Justify that the reaction 2 moles of sodium reacts with 1 mole of hydrogen gas and forms 2 moles of sodium hydride is a redox change. We can justify it like this. Since in the earlier reaction, the compound formed is an ionic compound which may also be represented as Na plus H minus. This suggests that 1/2 reaction in this process is 2 moles of sodium changes to 2 moles of sodium ion and 2 electrons, and the other half reaction is 1 mole of hydrogen gas gains 2 electron and changes to 2 moles of hydride ions. This splitting of the reaction under examination into 2 half reactions automatically reveals that here sodium is oxidized and hydrogen is reduced. Therefore, the complete reaction is a redox change. Let us perform an activity. Place a strip of metallic zinc in an aqueous solution of copper nitrate for about 1 hour. You may notice that the strip becomes coated with reddish metallic copper and the blue color of the solution disappears. This is a beaker containing copper nitrate solution. This is zinc rod. I am going to dip this zinc rod into copper nitrate solution. Dear learners, see what happens. After 1 hour, learners, you may notice that the strip becomes coated with reddish metallic copper as can be seen here, and the blue color of the solution disappears. Formation of Zn2 plus ions among the products can easily be judged when the blue color of the solution due to Cu2 plus has disappeared. If hydrogen sulfide gas is passed through the colorless solution containing Zn2 plus ions, appearance of white zinc sulfide, that is ZnS, can be seen on making the solution alkaline with ammonia. The reaction between metallic zinc and the aqueous solution of copper nitrate is zinc changes to zinc ions and copper ions changes to copper. In this reaction, zinc has lost electrons to form zinc ions, that is Zn2 plus, and therefore zinc is oxidized. Evidently, now if zinc is oxidized, releasing electrons, something must be reduced, accepting the electrons lost by zinc. You can see that copper ion is reduced by gaining electrons from the zinc. We may investigate the state of equilibrium for the reaction is represented here. For this purpose, let us perform one more activity. This is a beaker containing zinc sulfate solution, and this is a copper rod. I am going to dip this copper rod into zinc sulfate solution. We will wait for 1 hour and let us see what happens. After 1 hour, you will see that no visible reaction is noticed, and even if we pass H2S gas through the solution, no black PPT is formed, which indicates the absence of copper ions. We thus conclude that most of the reactants have been converted to products, and the state of equilibrium for this reaction greatly favors the product over the reactants. Let us perform one more activity in which I will take a copper rod which is dipped into a solution of silver nitrate. Again, let it be there for 1 hour, and you will notice that after 1 hour, you will be surprised to notice that the solution here, copper in solid state is oxidized to Cu2 plus in aqueous solution, and silver ions, that is Ag plus in aqueous state, is reduced to Ag in solid state. And you can see here the white particles deposited over copper rod, and this is silver metal. Equilibrium greatly favors the products, that is Cu2 plus in aqueous solution and Ag in solid state. The concept of occurrence of reaction with one more example. See what happens when metallic cobalt is placed in nickel sulfate solution. You may perform this activity under the guidance of your teacher, and you will notice that at equilibrium, chemical tests reveal that nickel ions in aqueous solution and cobalt ions in aqueous solution are present at moderate concentrations. In this case, neither the reactants, that is cobalt in solid state and nickel ions in aqueous solution, nor the products, that is cobalt ions in aqueous solution and nickel in solid state, are greatly favored. By comparing three reactions, we observed that zinc releases electrons to copper and copper releases electrons to silver. Electron releasing tendency of the metals is in the order zinc is greater than copper and copper is greater than silver. We would further love to include other metals in decreasing order of their tendency to release electrons when it is placed in a solution of other metal salts. The list so formed is called metal activity series or electrochemical series. The knowledge of activity series will help us to design a class of cells named as galvanic cells. We will study this topic in upcoming episodes. Thus, from the discussion till now, we conclude that oxidation is addition of oxygen or electronegative element, or removal of hydrogen or electropositive element, or loss of electrons. Reduction is addition of hydrogen or electropositive element, or removal of oxygen or electronegative element, or gain of electrons. Oxidation and reduction occur simultaneously in a reaction. A species which undergoes oxidation is a reductant, and a species which undergoes reduction is an oxidant. A metal activity series or electrochemical series can be designed on the basis of competitive electron transfer reactions. Let me leave you with an assignment. First question is, can we store copper sulfate in an iron vessel? Give reason for your answer. Second is, a freshly cut apple is almost white but turns brown after some time. Why? Third question is, the reaction is chlorine gas reacts with hydroxyl ions and forms hypochloride ion and water in liquid state. Represent the process of bleaching. Identify and name the species that bleaches the substance due to its oxidizing action. So, dear learners, I am sure that you are looking forward to some interesting and amazing concepts related to the redox reactions. But till then, take care. Thank you.